In this video, I want to look at the effect of multiplicity on the behavior of a polynomial graph at its zeros. So let's take a look at our first function. I have f of x equals x minus 2. If I need to find the zeros of this function, we set f of x equal to 0, so I get x minus 2 equals 0, so x equals 2. Here is my 0. And what's the multiplicity? Well, this x minus 2 factor only occurs one time, so I have a multiplicity of 1. And notice what happens to the graph. It crosses the x-axis at this 0 with a multiplicity of 1. Now let's look at our next graph, where I have g of x equals x minus 2 all cubed. The 0 is still the same. I set x minus 2 cubed equal to 0. I'll still get x equals 2. But now I have a multiplicity of 3. And looking at my graph, again, it's going to cross the x-axis at the 0. But in this case, the graph flattens out more near the 0. Now let's look at our next function. H of x equals x minus 2 raised to the 5th power. So I still have my 0 is x equals 2, but it now has a multiplicity of 5. Here's my blue graph. It again crosses the x-axis at x equals 2, but the graph is even more flat near the 0 than it was before. And lastly, let's look at j of x, which equals x minus 2 raised to the 7th power. Same 0 of x equals 2 with the multiplicity of 7. Same basic shape. The graph crosses the x-axis when x equals 2. So looking at my functions here, don't forget in f of x, my x minus 2 is raised to the 1st power. So in all these examples, I'm raising my factor to an odd number, 1, 3, 5, and 7. And in each case, the graph crossed the x-axis at the 0. Now we want to look at what happens when I have a factor raised to an even exponent, and that means my multiplicities will be even numbers. So let's look at f of x equals x minus 2 all squared. I have my same 0 of x equals 2 with a multiplicity of 2. Here is my 0 of x equals 2, but the graph does not cross the x-axis at x equals 2. It touches and turns around. So it is a different type of behavior. Now let's look at what happens when my multiplicity is 4. G of x equals x minus 2 to the 4th power. And I get the same basic shape, but my red graph is flatter nearer the 0 than my black graph. Looking at my next function, I have h of x equals x minus 2 to the 6th power. Again, an even number. Do I have the same basic shape? Yes. And finally, let's look at j of x. When I have x minus 2 to the 8th power, my multiplicity is 8. Do I get the same basic shape? Yes. So when the multiplicity is even, the graph is going to touch the x-axis and then turn around at the 0. So let's see if we can summarize that information. And here's my summary. If I look at the multiplicity of my 0 being an odd number, the graph always crosses the x-axis at that 0. If the multiplicity is 1, it will go straight across. But if the multiplicity is higher, a higher odd number like 3, 5, 7, the graph flattens out more near the 0, but it still crosses the x-axis. And finally, if the multiplicity is an even number, the graph touches the x-axis and turns around at the 0, so it will either look like this or like this.